If you did fail this test, there are retakes online already. So you can go on your own time and do the retest, okay? And it needs to be done by Tuesday night, okay? And so that's online. All right, let's look at some problems here. You guys picked up some notes. Today we're going to do backwards chain rule, okay? So I want to ask you guys, what can you do backwards, okay? I can do a few things backwards. Some of them I'll show you. Like I can walk backwards, okay? I actually did like not a video, but like a song with calculus one time where I actually did the moonwalk. So I actually can moonwalk because actually I practiced that because I actually was a child of the 80s too. And then something else I can do backward because I have kids that are your age. And a few years ago, they had that dance called the shoot, right? So I can actually like do the shoot backwards, okay? But those are some things that I can do backwards. But my most proudest talent is that I can actually do the chain rule backwards, okay? And so I'm going to show you guys how to do that today. And you guys will do that too. And then maybe if we, after AP exams, we can come up here and demonstrate what you guys can do backwards. Okay, let's look at this problem here. This is integration, okay? And when you see this problem, do you see a bunch of terms stringed together with pluses and minus signs? When you see that, okay, you should be thinking to yourself, okay, Patrick, you're with me on this? You should be thinking to yourself, I thought I got to do one problem, but, oh boy, I get to do 3. Do you guys see that? Are you thinking that to yourself? I knew it. Okay, so what we're going to do is we're going to do the integral of 2 sine x first. What's the integral of 2 sine x? Okay, minus cosine. So it will be 2. You can pull out the 2, it's like a scalar, times minus cosine x, which really is just negative 2 cosine x. All right. What's the integral of 7? What's the integral of secant squared x? Tangent x, right? The negative 7 is like a scalar, so you can pull it out. So this will be negative 7 tangent x. Okay. Of course, there are charlies to each of these, but it'll be Charlie plus Charlie plus Charlie, which would just end up being 1 Charlie. Okay. And then plus pi x, guys. The derivative of what will give you pi? Pi x. So this becomes plus pi x, and don't forget your Charlie. Okay. Does that make sense to you guys? Okay, let's do differential equations. So you had a problem like this on your homework, or I think a couple of them. And so what we want to do is make sure that you can integrate, but also figure out what the original f was to begin with using differential equations. Okay. And so these are problems just like your regular integration problems, but these are problems where you actually solve for your c. All right, so if I have the second derivative, okay, and the problem says solve, then the problem says solve, okay. If I take the derivative, okay, of f, I get f prime, and the derivative of f prime, I get f double prime. Up here, if it says solve the differential equation, what is my goal? What am I trying to find? My answer. How do I know when I'm done? F of x. Does that make sense? You're trying to find f of x. Okay, you need to know what you're trying to find. So if it says solve the differential equation or find the particular solution, okay, or if it just even says solve, okay, what you're trying to find is f of x, which is really y, either or, okay, and your answer is going to be some sort of algebraic equation. It's not going to be just something simple like 5, okay? All right, so if I have f double prime and I want to move to f, do you guys see what I'm going to have to do 2 times? Take the antiderivative 2 times, all right? So let's just do it. Just like derivatives, I can take the antiderivative of both sides of an equation. So the antiderivative of this side is equal to the antiderivative of this side. The antiderivative of f double prime is f prime, okay, plus c. Okay, but I'm just going to move my c to the right side because there are going to be 2 c's anyway. The antiderivative of 2 is 2x, right? But don't forget Charlie, all right? So at this point, what I want to do is take a pause and find out what Charlie is here. And to find out what Charlie is, I go look at my conditions that they give me, okay? And this condition here tells me that any time that x is 4, okay, then f prime of 4 is going to be 1. Okay, and that tells me that C is negative 7. C is negative 7 here. All right, and that's helpful because what that says is this problem here, this f prime of x, is actually 2x minus 7. Okay? All right. Now that I know f prime of x, I'm thinking to myself, that wasn't even my goal. My goal was to find f of x, right? So what I need to do is do it again. How do you move from f prime to f? You take the antiderivative, okay? So I'm going to take the integral of both sides. The integral of f prime is f, okay? There's a plus Charlie, but I'm going to move all my Charlies to the right, okay? This becomes 2x squared over 2 minus 7x. Don't forget Charlie. So this becomes f of x is equal to x squared minus 7x plus Charlie, which is a great answer. But the problem is I still have Charlie in there. How do I find out what Charlie is? Plug in right there, okay? So this will be f at negative 1. Everywhere there's an x, I'm going to put in 1, okay? F of negative 1 I know is negative 2, okay? Did I do that right? So Charlie is going to be negative 10, all right? Okay, so I found Charlie, and that's great, but my goal wasn't actually even to find Charlie. My goal was to find f of x, okay? So I'm going to replug that in. F of x equals x squared minus 7x minus 10, and that is my final answer, okay? Can you guys do that on your own? All right, let's do another problem. Sometimes, guys, there are integrals with trig functions in them, okay? And remember, guys, there's no quotient rule, okay? There's no quotient rule in integration, right? There's no product rule either. There's kind of a product rule, but it's not anything that we want to know about right now, okay? You're going to have to know all of your pre-calc formulas, okay? So I'm pretty sure I'll have them on a slide later on or something like that, but you guys missed out because of COVID. Usually, SciWoods puts together all your formulas with the pre-calc. Does that make sense? And then I tell you guys, bring them in, and then you guys can look at them, okay, and remember them. You actually can't use them for your test, but you need to remember them, okay? So I wrote a few here to help us out. And so when you have problems like this, and you might have to use the Pythagorean identities too, you know, the I cut cheesecake ones and stuff too. When you have problems like this, you want to rewrite it in a way that you can actually simplify it into some sort of integral that you know. And so it really just is a manipulation problem. It's not like I know what to do coming into the problem, okay? So a lot of times I just like rewrite the problem into a way that it's an integration that I've memorized. And all the integrations I've memorized are on that board back there behind Hanukkah, okay? Those are all the integrations that you should have memorized too, okay? And so eventually you'll need to write all these formulas somewhere because there's going to be a bunch of formulas that you need to know, okay? And those are the ones that you need to know. So you need to know them so well that you recognize it. So if I look at this, is there a way to move this formula into one of those integrations that I know? And those integrations I know are actually also on your notes. So if you pull out your notes from the last notes that you had, they're all listed there too, okay? What is this? This is actually tangent x times secant x. Do you guys see that? And if you don't, it really is just practice, okay? After a while, you see it. All right? Yeah, Patrick? Are you good? Oh, you're good. Okay. It is. Okay. Yeah, you should know from memory. But eventually we'll do a lot of these too. Okay, guys, the integral of secant x tangent x is what? Secant x. Okay, and that is your answer. Okay. Notice that at this point all your x's are just x's. Okay, I haven't put in x squared, 2x, any sort of anything very complicated for your x, okay? So that's what we're going to do next, okay? So let's go ahead and talk about the opposite of chain rule. At this point, we've only done the reverse power rule, okay? But I want to talk with you guys. If I had this problem and I wanted to take the derivative of it, so I want to take the derivative of x squared plus 1 raised to the 5th over 5, okay? What would the derivative of that be? When you say 5 times 1/5, which is 1, right? Leave the inside alone. Take the power down by 1, and then multiply by the derivative of the inside, and that would be your answer. Do you agree? That's a derivative. So that means this is the chain rule. That means the antiderivative of that. So if I do the antiderivative of 2x x squared plus 1 raised to 4, which is your next problem, okay? If I wanted to do the antiderivative of that, Do you agree that that would be going backwards on what I did with the chain rule? Okay, so let's talk about what I did with the chain rule. What I did with the chain rule is first I multiplied by the exponent, then I subtracted 1 from the exponent, then I multiplied by the derivative. Okay, you guys good with that? So let's walk forwards. When we walk forwards, okay, what we do is we multiply by the exponent, we subtract 1 from the exponent, okay, then we multiply by the derivative. Okay, so now I'm going to walk backwards on the chain rule. Okay, what I'm going to do is I'm going to add 1 to the exponent, I'm going to divide by my new exponent, then I'm going to divide by the derivative. Okay, and I'm going to go back to what I had originally. Okay, so let's see how you do that. What I'm going to do is I'm going to add 1 to the exponent. So this is exactly like what you did in your homework for my math lab. Hopefully you did it. Okay, you're going to add 1 to the exponent. You're going to divide by the new exponent. Okay, then you're going to divide by the derivative of this x squared plus 1. So the derivative of this x squared plus 1 is 2x. Okay, so what happens is this 2x cancels with this 2x. Okay, the x's cancel out. So what you have left is x plus 1 raised to the 5th power over 5 plus Charlie. Okay, so that's walking backwards on the chain rule. Okay. Did I not? Oh, yes, x squared plus 1. Thank you. Okay. Now, you can see it gets kind of complicated. And also, you can see, had I not had this 2x here to begin with, the 2x's wouldn't have canceled out. Okay. So the problems that I give you are actually carefully concocted so that your 2x's will also cancel out, always cancel out. Does that make sense? It's kind of like when you started multiplication and division, and your teacher gave you division problems. None of your division problems had remainders to begin with. Does that make sense? So we're going to start out, all your problems, none of them will have remainders to begin with, meaning all these x's will cancel out, okay? Later on, we'll work some tougher problems where your x's don't cancel out. We'll figure out what to do with them. Okay, so let's go ahead and, oh, okay. Actually, I need to tell you one other thing. What we just did here was a method called pattern recognition, okay? What we did was we recognized the pattern here and we walked backwards on the pattern, okay? From here on out, or for most of the next few days, I'm going to do a method called U substitution, okay? Pattern recognition is a shortcut, so I'm just going to let you know, it's a shortcut for U substitution. U substitution is the real method that you're supposed to use. So I'm going to teach you the real method. The AP test expects you to use the real method. Okay, so just letting you know, AP expects the real method. But sometimes they'll test you on it, and if they test you on the real method, it will just be one question. Okay, but most of the time, pattern recognition, if you can do it, takes less time. I'm going to start with U substitution, and the reason is this. Even though I just taught you pattern recognition, I taught it to you, so if you want to, you can use it, all right? But pattern recognition doesn't work 100% of the time. U substitution works 100% of the time. U substitution takes longer, but it doesn't take as much intuition. Pattern recognition, you save time, but it takes a little bit more intuition, okay? So I want to say, I don't really care what method you use, but you will need to know how to use U substitution. So I'm just going to teach you using this other method called U substitution. And you guys can look at it. I'm trying to get to my first problem. How come this is not advancing? You can look at it. Here it is. And see how to do it. And then if you want to use pattern recognition, you're welcome to use that. But you still need to know how to do U substitution. Okay? Yes. Okay, so I'm going to do the same problem, but I'm going to do a method called U substitution. And this is what you do. First, you find your inside. You find your U. Okay, you find your inside parentheses, your G of X. Okay, and you just state what it is. Okay, then you take the derivative of it with respect to X. So du dx is equal to 2X. Okay. Then you solve for dx. So dx is equal to, and this is really a cross-multiplying problem, okay, that I'm going to do fairly quickly. And so dx is equal to du over 2x. Okay, this is called U substitution because you substitute two things. You substitute your u and you substitute your dx. The problem, it really should be called the u dx substitution method, not just the U substitution, because you substitute your u, but you also substitute your dx. So when I substitute my dx, what I get is 2x times u to the 4 times, this is what my dx is. So times du over 2x. Okay, so what did I do? I found my u. Okay, actually, believe it or not, the hardest thing to do is finding the right u. Okay, then you take the derivative of your u. Then you solve for dx. Okay, then you substitute two things. You substitute your u and you substitute your dx. If it is not your u or your dx, you don't substitute it at all. Okay, all you substitute is your u and your dx. Then what you want to do is get this problem in terms of all u's. And so your x's have to cancel out. Okay, it turns out my 2's cancel out also, which is great. But the truth is that 2 is a scalar, so it really didn't have to cancel out. But the x's must cancel out, because in the end, you must have a problem with only u's and no x's, okay? If you have x's, then it's kind of like implicit differentiation. Does that make sense? You have to do something special, because you're taking the integral with respect to u, not with respect to x. So you got to try to get rid of all your x's, okay? And this method helps you get rid of all your x's for the problems that I'm going to give you. All right, then when you're at this point, it should be an easy antiderivative, okay, just like you did on Monday. If it's not an easy antiderivative, or if it's not a formula that you've memorized, it's either going to be an easy antiderivative or it's going to be a formula that you've memorized. If it's not one of those, then you did something wrong. You need to go back to the drawing board, maybe pick another u, or maybe find your mistake, okay? So right here, do you see that this is really just equal to add 1, divide by 5. This is really equal to u5 over 5 plus Charlie. And that's my answer. It's just not the right answer. It's a great answer. But remember, my u is something that I made up, okay? So you have to go back and say, oh, the u is x squared plus 1. Put x squared plus 1 back in, okay? And that is the right answer, okay? And that should have been the same answer I got when I did pattern recognition, okay? And I know some of you guys are thinking pattern recognition is way easier. I agree with you, okay? But pattern recognition takes more intuition, and it doesn't work with every problem. So if you guys will be patient with me, I'm okay with you guys using pattern recognition, but I want to make sure that you can also do U substitution also, okay? So let's go ahead and go with this problem here with U substitution. All right. Sometimes, just like in derivative land, we have to rewrite the problem. Okay, so when I rewrite the problem, this is what I get. Is that a 1/2? Yes, that's right. Okay. And I'm going to do U substitution, okay? So I have to figure out what my U is. Your U is usually what's in parentheses, okay? If you have more than one thing in parentheses, then it's usually whatever has the power to it, a funky power to it, or the biggest power, usually, okay? You find your U, then you take the derivative of your U, okay? Then you solve for dx. Okay, we're going to do all the same things. You find your u, take the derivative, solve for dx. Then you do the u substitution. U substitution means you solve for two things. You solve for your u, you substitute your u, or you substitute your dx. You substitute two things, okay? Then you rewrite the problem. So now this is the integral of 3x squared times u to the 1/2 times du over 3x squared. All right, at this point, I want to change everything into u's, okay? And so all my x's need to cancel out. So yes, using real algebra though, guys, not the fake stuff. Using real algebra, your x's have to cancel out. So x squared divided by x squared is 1, okay? It turns out 3 divided by 3 is also 1, but I got to tell you, it's not so important that the scalars divide it out, because scalars you can pull out of an integral. But the x's must cancel out. And so my new integral is the integral of u to the 1/2 du, okay? At this point, it must be an easy antiderivative, something that I did on the first day, and it is. Or it should be something that's on my formula sheet, okay? This is an easy antiderivative. What I do is I add, oops, this is 2 over 2. I add 1, divide by 3/2, but dividing by 3/2 is the same as multiplying by what? 2/3. So this answer is 2/3 u to the 3/2 plus Charlie. And that is a great answer. It is just the wrong answer, okay? Why is it wrong? Yeah, I need to replace a u. The u is something I made up. It wasn't even in the original problem, okay? So you need to go back and say your u was x cubed plus 1 raised to 3/2 plus c, and that is the right answer. Okay? You do. It's actually, if you master it, it's actually more helpful when we get to BC. Okay? Well, actually, they're both helpful. But when we start doing trig substitution, which is something your mom never told you about, that you'd have to learn. If you are good at U substitution, you're good at trig substitution. Okay, so let's do another one. This problem here. So sometimes there's multiple possibilities for your U. So let me just rewrite this to make sure you understand what I'm saying. Because this secant x is really secant squared x, right? Secant x squared times tangent x plus 3 dx. Okay, there are actually several possibilities for your u. I can think of it. Your u could be secant x, right? Your u could be tangent x plus 3. So there's a little bit of a strategy on how you find your u. And the strategy is this. You just practice a lot, and eventually you'll figure out what to do. Because what will happen is you'll waste 30 minutes of your life, and then you'll be like, I'm never going to do that again. Does that make sense? Like, you'll just keep on wasting 30 minutes of your life, then you'll be like, okay, I'm going to figure out the strategy. But the main strategy is this. The derivative of tangent is secant squared. Like, you know that. Does that make sense? So that means this is going to be your u. Like, if the derivative of secant was tangent, does that make sense? The thing is, the derivative of secant is secant x tangent x. Does that make sense? So, that actually, no, that wouldn't work here. But if you try making u your secant x, it's not going to, the x's aren't going to cancel out here. And if we had time, which we don't today, but eventually one day we'll have time, and I'll show you why it doesn't work. But your u here, the best u, and I actually think the only u that will work in this problem, is setting u equal to tangent x plus 3. On your own time, set u equal to secant x, and you'll see that it won't work. Okay? All right, right here, the derivative of u is actually the derivative of tangent x plus 3, which is secant squared x plus 0, right? Okay, you solve for your dx, so dx is equal to du over secant squared x. Okay, and you substitute two things. You substitute your u and you substitute your dx, okay? So I'm going to circle my u and I'm going to circle my dx, okay? Students who are not keeping track of this and trying to take shortcuts, okay, substitute random things in, and then it's really hard for me to see why you did what you did, and it's really hard for you to get the right answer, okay? So please take it one step at a time. Don't do a bunch of things at one time, all right? When you substitute in, you got to use real algebra, though. Your x's should cancel out using real algebra, okay? When you're done canceling things out, okay, you should have no x's. You should have only u's, all right? And then you should be in a place where you just use an easy antiderivative rule, easy reverse power rule, or it should be something that's on your formula sheet, okay? This is an easy reverse power rule. This is u squared over 2, right? 1 plus 1 divided by 2 plus Charlie, okay? And that is my answer. Again, it is just the wrong answer. It's a great answer. It's just the wrong answer because your original problem never had a u. So you need to go back, put your u in, and that is your answer. Okay, you guys feeling comfortable with that? And once again, there is a way you could do it with pattern recognition, okay? And if you can figure that way out, then more power to you. You'll do some problems faster. And eventually I might go to some pattern recognition problems. But I just want to point out to you guys that I want you guys to start out with U substitution to begin with so you don't get confused. Okay, let's skip this problem. I want to go to the next one, and then if you have time, we'll go back to this one. Okay, let's go to this one. This one's a little bit more fun. All right. What is your U in this problem going to be? Okay, so go ahead and write it. See if you can take this as far as you can without me. Okay, do your U, take the derivative, solve for dx. If you're stuck, feel free to look on the board. Yes. Oh, I'm almost done. Okay. So guys, did you get u to the 4th du? Did you pull out a scalar 2/3? Okay, so remember, scalars don't have to cancel out. So guys, the integral of u to the 4th, this should be something that you can do from the first day of calculus, the first day of integrals, which was Monday. Or it should be something on your formula sheet. So this is actually 2/3 times u to the 5th over 5 plus Charlie. Do you guys see that? So that is my answer, but I can simplify a little bit. This is really 2 over 15, right? U is actually x cubed plus 5 raised to the 5th power, and don't forget Charlie. Did you get that as your answer? And if you did, you're probably in very good shape, okay? Let's look at let's look at the next one where you have to rewrite this thing. This one right here. Okay, your answer should be, here, I'll write it up here. Let's go back to this, let's go to this one, guys. Hold on, Patrick, I just want to make sure we have enough time. So your answer for that last one should have been x to the 3rd plus 5 over 5 divided by 3x squared, 2, was it 2 over 15? Is it 2 over 15? Okay, 2 over 15 plus c. That's your answer to the last one. Okay, I'm kind of rusty on my pattern recognition. Okay, right here, this problem here, guys, you need to rewrite it. And I'm going to rewrite it wrong. And can you guys tell me what I did wrong? Because this is what students do. What did I do wrong? Yeah, it should be a negative 1/3. Okay, yeah, that shouldn't be a positive, it should be a negative. So that's what students do wrong. So please, guys, get comfortable with rewriting these problems, but make sure you rewrite it correctly, or else all of your answers will be wrong. Okay? Figure out what your u is. And again, your u is usually what's in parentheses. Usually I'd say 90% of the time, okay, your u is whatever's in parentheses and you'll get it right. Or it's whatever's raised to the funkiest power, okay? Then you take the derivative of your u, okay? Then you solve for dx, okay? It's all the same method. Then you substitute two things. You substitute your u and you substitute your dx. This should be called u dx substitution, okay? I'm going to circle them, okay? Don't substitute anything else. Okay? At this point, your x's should cancel out. You want to get to only u's, okay? If you have x's still in there, you're going to have to do implicit integration. Do you know how to do implicit integration? Me neither, okay? There's no such thing, all right? You got to figure out how to get all your x's gone, all right? Then you're going to pull out a 1/4. Pull out your scalar. And at this point, I should be at a place where it's an easy reverse power rule. Okay, I know it's not super easy, but it's doable. Okay, or it should be something that's on your formula sheet. All right, so I'm going to add 1, divide by 2/3, which is really multiplying by 3/2. Right? So this becomes 3 over 8, u to the 2/3 plus Charlie. Okay? And so this is going to be 3/8. My u is actually 2x squared minus 1, 2/3 plus Charlie, and that is my final answer. Okay? All right. Now we're going to get to trig functions. So to this point, I never gave you a cosine 4x, right? All your cosines were just cosine x's. Okay? So what do you do if you have a cosine 4x? Well, what you would do is you would make this your u. Okay, so u is equal to 4x. Okay, and the number one wrong thing students here is they don't do u substitution, and that they say this answer is sine 4x plus Charlie. And I want to tell you that that is wrong. Okay, this answer is not sine 4x. Okay, and I'll show you why. It would be if this were x, you would just carry the x. But if this was 4x, then your derivative is actually 4, and your dx is actually du over 4. Okay. And then you have to do u substitution, If you do U substitution, okay, you have to substitute two things. You substitute your u and you substitute your dx. So this becomes the integral of cosine u times du over 4. Okay? Do you see what my scalar is that I can pull out? Do you see that it's a 1/4? Okay, so I'm going to pull out the 1/4 scalar. So what I get is the 1/4 times the integral of cosine u du. And at this point, guys, remember, all your x's should be gone. You should have no x's. If you have x's, you need to go back to the drawing board and figure out a new u. Find your new u. Okay. And then what you want to do is say, right here, I should have an easy reverse power rule, or this should be on my formula sheet. Is this on your notes? Is this a formula that's on your notes? Yes. What's the integral of cosine u? Sine u. Positive or negative sine u? Positive sine u. This is 1/4 sine u plus Charlie, and that is your answer. Okay? It's not the right answer, though. It's a great answer. What you need to do is go back and replace your u. So this is 1/4 sine of 4x plus Charlie. And the replacing the u is so easy, but you'd be surprised by how many students put random u's in there. Okay, so make sure you replace it with the right u. I'm going to skip the 7x side. If you want to jot this down, the answer on the 7x side is negative 1/7 cosine 7x plus c. Okay, and you can do that one on your own. I want to move to the next problem, which is a little bit more difficult for students. This one right here. This one, the x over 3. Okay. With this problem here, your u is kind of funky, but what you need to know is, you guys kind of recognize it. Isn't this something that you know? Does that make sense? It's something that you know. So this is why it's so important to know the derivatives and antiderivatives, because this is actually something that you know. Yeah, it's negative cosecant, right? And because you know this, then that's why I know my u is equal to x over 3. Okay, and this is kind of hard because usually you only plug in one u, but because you know this formula, you'd actually plug in 2 u's for this. So let's just see how this works. Okay, same thing. We're going to take the derivative of x over 3. What in the world is the derivative of x over 3? 1/3. Is everybody good with that? Okay, because the x's bounces out, right? So that's really 1 du dx equals 1/3. And once again, you solve for dx. Now this dx is a little bit funky because we're used to having fractions, but it doesn't always have to be a fraction. So right here, when I solve for dx, I actually just get 3 times du. And then I substitute 2 things. You substitute your u and you substitute your dx. But in this situation, you have 2 u's. You have to be careful. You can't always just substitute like this when you have 2 u's. But I have 2 u's because I actually knew this integration here. Like I actually knew there was an integral for that. So I'm going to go ahead and rewrite this. So this is cosecant u, cotangent u. Oh, actually, there's a typo in your notes, right? Sorry. Yours says cosine, but it should say cosecant. Okay, in your notes. Sorry about that. So this is cosecant u, cotangent u, and then du is 3, dx is really 3 du. Okay, is that good so far? Okay, pull out your scalar. So I'm going to pull out the 3. Okay, and at this point, I should have no x's, which I have no x's, which is great, and I should have either an easy reverse power rule problem or something that's on my formula sheet. Okay, is this on my formula sheet? Yes. Okay, so this is actually negative cosecant u. So this answer is negative 3 cosecant u plus c. And you could have negative 3c if you want, but the thing is, you didn't know what c was to begin with. It's some constant. Now it's a constant multiplied by negative 3. It's still just some c. Okay? And this is your answer. It's a great answer. It's not the right answer. Okay? To get the right answer, you want to go back in, okay, and put in your u. Okay? So that's not really bad until you do it by yourself. Then it becomes bad. Let's do the next problem right next to it. This x squared secant squared x third minus 5. Okay? What do you think your u is going to be on that problem? Okay, go ahead and try it. Make your u equal to x cubed minus 5. Take the derivative. do your U substitution. You're going to substitute two things. You're going to substitute your U, and you're going to substitute your dx. And you have to ask yourself, do your x's cancel out? Because you're not allowed to have any x's. There's no such thing as implicit integration. Okay, do my x's cancel out? Yes, okay. Pull out that scalar, guys. And this should be an easy antiderivative, okay, reverse power rule, or it should be something on your formula sheet. Is this something on my formula sheet? Yes. Okay, what's the integral of secant squared u? Tangent u plus Charlie. Okay, and that's a great answer. Just make sure you come back in and put in your u so that you can get the right answer. It was a great answer, but it wasn't the right answer. And make sure you put in your u. Okay, the next two actually are ones that students have trouble with. I'm not really sure why. I think it's just practice. The tricky thing about the next two is that it's really hard to figure out what your U is, okay? And so, again, I'm prompting you on what your U is, and so it's seeming kind of easy right now because everything's working out. But when you're on your own, you might pick the wrong U, and that's totally okay. Okay, when I was in high school, I picked the wrong U a lot of times, okay? But what happens about picking the wrong U a lot of times is that eventually you won't pick the wrong U a lot of times because you'll be like, I just wasted so much of my life picking the wrong U. Okay, and you'll figure out a strategy to pick the right U. But you got to figure out that strategy on your own, kind of. Okay, so I don't know if you guys see this, but U here could be cosine x or it could be sine x. Do you see that? Okay, and I think, I'm not sure, I have to do it, but I think it only works if your U is cosine x. It might work. I almost want to do it, but I don't want to waste time. But it will work if your U is cosine x, okay? And then what you want to do is you want to take the derivative. Yeah, actually it won't work. It won't work if you make U sine x, okay? And so then you take the derivative of your U, and what's the derivative of cosine x? Negative sine x. Yeah, be careful about that because now we're doing derivatives and integrals, okay? And your dx is going to be negative du over sine x. Okay, now we're going to substitute two things, okay? We're going to substitute our u, which is this right here, and we're going to substitute our dx, which is this right here. Okay, so let's see if we can substitute them. And our x's are going to need to cancel out. And you have to use real algebra. So do all my x's cancel out with real algebra? Yes. Do you see the scalar on this one that I pull out? The scalar is -1. Do you see it? So I'm going to pull it out. And at this point, I should have an easy antiderivative problem, reverse power rule, or it should be something on my formula sheet. Okay? This answer is just u5 over 5 plus Charlie. Okay? So this one would be negative u, and my u is cosine x, raised to the 5th power over 5 plus Charlie. Make sure you put those parentheses, guys, around the cosine x, or I'll count it wrong, because cosine x to the 5th is not the same thing as cosine x raised to the 5th power, okay? So put those parentheses around the cosine x. All right. How are you guys feeling? Good? Okay. I know I'm going kind of fast, so let's go to this problem here, okay? This problem here is another one of those where students are unsure of what the u should be, okay? Yes, that's actually the right answer. Okay, sometimes your u can be multiple things, and sometimes it can only be one thing for your x's to cancel out. So it takes a little bit of just practice to figure out what to do. But if you make your u here equal to secant x, I don't think your x's are going to cancel out. Okay, you could try it, and we'll try it another time. But what I want you to notice is the derivative of tangent is secant squared, right? So actually, I'm going to change this back to, I think we're used to having the squared inside here. So I'm going to change it back to that. The derivative of tangent is secant squared, right? So because the derivative of tangent is secant squared, I'm going to make my u equal to tangent x. Okay, it's just kind of like a smart thing that you figure out after a while, because you actually don't want to make the derivative your u. Okay, because you want the derivative to cancel out. Okay, so if I make my u tangent x, this becomes the derivative of tangent is secant squared x. Okay, so dx is going to be du over secant squared x. You substitute two things. You substitute your u and you substitute your dx. Okay, so this becomes the integral of u raised to the 5th power times secant squared x times du over secant squared x. All right, do you see the strategy kind of? Because you kind of want, you want to take the derivative, and when you take the derivative, it's going to cancel out, okay? It's really a chain rule what we're doing, okay? My x's need to cancel out, okay? If they don't cancel out, then that means I need to go back and set my u equal to something else, okay? So this would be u to the 5th du, okay? This should be an easy antiderivative, or it should be a reverse power rule problem, or it should be a formula on your formula sheet, okay? This is really just u to the 6th over 6, okay? But that's a great answer. It's just not the right answer. Make sure you come back and put u back in, okay? And that is the right answer. How are you guys feeling? It's on my math lab, I think. Or was there homework even before that? Oh, no, I don't think I checked it in this class, right? That's okay. I made everybody present anyway. You guys are good. But I do need to eventually check it just for a grade, but not for your assignment. Okay. All right. We have a few minutes in this class. Let's keep on moving in this class. I want to see if you guys can do the next one. Okay. Oh, wait. This one was the next one. Okay. This one right here. Oh, maybe it's not the next one. Oh, it's here on the bottom. Okay, on the bottom. Is that the same problem? No. The one with the 2x. Is it this one? Okay. This one's a little bit of a tougher problem. Okay. Let's see if we can do this one together. Okay, you're going to rewrite this problem. So this is the integral of tangent 2x raised to the 5th power times secant squared 2x squared dx. You guys see that? Okay. The hardest thing is trying to figure out what your u is. Okay. Right now, I'm just going to make my u equal to tangent 2x. Okay. But on your own, you might play around with it. Try making it use different things, and you'll see why things work and why they don't work. Okay. The derivative of tangent 2x. The derivative of tangent 2x is secant squared 2x times 2. Right? Do you guys remember this? Because it's the derivative, the derivative of tangent u is secant squared u times du dx. And this right here is the du dx. Okay? You guys good so far? Then you want to solve for your dx. Your dx is going to be du over 2 secant squared x. You guys good with that? Then you're going to substitute two things. You're going to substitute your u, and you're just going to substitute your, did I do something wrong? Oh, yeah, you're right. Sorry about that. Thank you. It should be secant squared 2x times 2. Thank you. So this should be a 2x. Yes. Okay. Now you're going to substitute two things. You're going to substitute your u, and you're going to substitute your dx. So this is my u right here. This is my u right here. And this is my dx. So rewrite that, okay, with those substitutions. Yeah, the hardest part is finding your u. And so a lot of times when you're stuck, I can go by you and say, make this your u, and you can fly with that, okay? So the hardest part is finding the right u. Okay, so right here, guys, using real algebra, do my x's cancel out? Are these actually the same? Yes, they actually are. So this will cancel out. So what I get is 1/2 on the outside, u to the 5th du. So even though this problem seems so complicated, it whittled down to just the integral of u to the 5th du, which I know what that is. That's 1/2 times u to the 6 over 6 plus Charlie, right? Okay, but what is that really? That is really, the u is really this giant tangent 2x. So this is really 1 over 12 times tangent 2x raised to the 6 plus Charlie. You guys comfortable with that? Okay, so you guys are armed and dangerous for your homework. Please skip for now. Again, skip number 13 and 14 on your homework. You're not armed for that yet, okay? But we'll go back to that on Monday, okay? But every other problem, unless I'm missing it, you should be able to do.